Hey everybody, Mr. Bell's here. Again, I have an appointment for my mom today. I have a sheet for you guys. It's on statistics. This is something I want you to be able to fill all the way out, but don't just fill it out because you're watching the video. Make sure that you understand all this stuff. Everything that's going to be on here is going to be on your test. And if you can't do it on your own, you don't know how to use your calculator for it, it's going to be a rude score for you. So again, make sure that you're staying on top of it. It's on both sides. You know, you can print this off the Google Classroom. I'm going to have a couple of the things in the class too. I'll go make some extra copies for it. Okay, so here we go. Step number one. This is all your data, and you guys know you can pause the video and enter all that data in. I already have it into my calculator, so I'm going to go ahead and go from here. Whenever we have a data set, and this is a data set that we've already used, but I wanted it to be something that you guys were familiar with. So 60 random adults, and this is their IQ scores. IQ stands for Intelligence Quotient in some tests that they did and where those scores range from. So again, first you're going to go on your calculator, you'll hit your stat button, you'll hit edit, and you're going to enter all that data into L1. Make sure that when you're done, your last number 89, which is this one right here, if you click on that last spot just like that, you can see that it'll say list 1 and 60 for the number 89. That tells you that there's 60 numbers right in that spot. Okay, we know that the mean is the average of all of these things, so what the typical IQ score is for all of that. We also know that mean is represented by something called X bar, or the average. Median, if I rank them from low to high, it's the one that is directly in the middle. Remember, with an even number of numbers, like in this case 60, then there isn't a middle number. You have to take an average of those ones, so you would do 60 plus 1, which is 61 divided by 2, 30.5, which means you'd average the 30th and the three first numbers from this thing. Range is highest minus lowest. Standard deviation, I'm going to have you write down on this, and it's too difficult for me to go through the video on it right now. But that was what we're going to teach tomorrow during class, and then outliers that we've talked about before. So here we go. I'm going to take it, and once you have it all in your calculator, our buttons are going to be again stat, and then over to calc, and number one variable stat, enter. I want to make sure my data is in L1. It will automatically default on the older calculators to L1. I'm going to go ahead and do that and calculate it. So go ahead and put these numbers in to our spots that we have right here. So I have a mean, an X bar of 115.083 repeating. A median, if I scroll down here, you can see that median is 114. That's also known as Q2. A range is the highest number minus the lowest number. So I got a high of 145 and a low of 82. So that's 18 under 45, which is 63. Standard deviation is, stat, calc, one variable stat, enter. Standard deviation is this one right here with a little, looks like a little O with a top hat. So I'll draw that out here. It's kind of like that. And that number is 14.67. And I will tell you right now that it measures the spread of the data. So if I had data points like this, spread out a lot like this, their standard deviation would be higher than if I had data points that were like this, that were all congested together. Okay, so that's just a generic way of looking at it. You can see that these are spread out quite a bit between 82 and 140 something is the highest. Outliers, we're going to check on that from the box and whisker plot. So again, I'm going to go show you on your calculator how to be able to do that. You can fill it in on your sheet. I'm not going to do it on the sheet. Make this and big for you so you can see this. So again, stat plot is right up here at the top. You're going to go second in stat plot. Hit on for enter. You're going to choose L1. L1, enter. Make sure it's on a box and whisker plot with outliers to show. And then I'm going to choose window. My IQ scores went from like 70 to 160. So I'm going to go ahead and do that. And you can see that I have that. There might be some other stuff on your screen that's just extra things that are left over in your y equals. You can get rid of those. Okay? You get trace on there. It'll tell you what all of the scores are, so make sure you transfer that information right now to this. And kind of one of the things I want to point out is you noticed it before that this data is very symmetrical. We said that it follows something called a bell-shaped curve. Another key buzzword is that this is a normal distribution. And that's going to be big for next week also. Okay? Normal distribution. So go ahead and copy that in. Make sure you put all your labels and stuff, put a topic on the thing. So what can you tell about the data from looking at the box and whisker plot? It's follows a very normal distribution. Now we're going to try and see if we can do a histogram. So remember, histogram is the box and whisker type plot. So I'm going to go here, second, y equals, hit enter. I'm going to choose the third one, just like that. I'm still going to use L1. And if I go to my window now, remember these things change it. So I'm going to show you a couple of them. If I change my X scale, or leave it at 50 right there, you can see I just got I got a big old honking box. If I change my X scale to 10, you can see that I see a few more boxes on here. But you can see my Y max is only at 3, so let's make my Y max 15. And now you can see that it's a little bit better distribution of what's going on. Let's make this 20, and then graph, and now we can definitely see it. Okay? Now what I want to do is take this information. Remember that this has both an X scale, you can see it here, trace. These will go from 80 to 90, 90 to 100, 100 to 110, and so on down the line. Make sure you have that. And then it also has a number. So there's 3 in this column. There's 6 in this column. There's 12 in this column. So it has a vertical scale. Make sure that you transfer that to this down here. And then it says, what can you tell from data from looking at the histogram above? Yes, it follows a normal distribution. It should be very symmetrical. Good deal. Now, at this point, I know I'm only 8 minutes into the video, but you should probably be 25 minutes or so into this activity. Okay, here we go. There are 2 more things that we're going to talk about. They're going to be things called percentile rank and z-scores. Percentile rank basically shows that if you have a handful of people, you have a whole bunch of people in this group or this category, it shows how one person ranks compared to everybody in this group. Okay? Now, it could be that you could take somebody who's really, really good in a different group, right? This group over here. Okay, so maybe this is all of the baseball players at Gull Lake. Okay, all the baseball players at Gull Lake. And you might find this person right here, and they are the best baseball player at Gull Lake. They're really flippin' awesome. Their percentile rank in this population would be really, really high. They'd be at like the 99th percentile, so they're better than 99% of the people in their group. However, if you took that person and you put that person in this group right over here, and this group was current players in the MLB, in the Major League Baseball, that person who had a really high percentage rank right here is now going to have a percentile rank of probably 0, which means they're not better than anybody in this group. So having a percentile rank doesn't mean that you're amazing. It doesn't mean that you're horrible. It just simply classifies where you are compared to the rest of the people. Okay? Z-scores, on the other hand, Z-scores are things that are called standardized scores, and they allow us to compare standardized scores. They allow us to compare to not just a whole population, but across populations for it. Okay, and I'll go through that stuff. So here we go. It says Tom's IQ score was a 117. How many people did Tom score higher than or equal to, not including himself? So we look back at here and we go, oh, look at all these numbers. 117. So how many did he score equal to or better to? Well, I could count up all the ones that are 117s or lower, or maybe I could just sort it on here like this. So here we go, on my calculator, on stat, sort A, I'd sort A2, I'm going to sort L1, I did that, I go to stat, I go to edit, and you can see that if I go to my 117s, there are 3 117s, right? 3 117s, so the 34th, 35th, and 36th number. So it says specifically, how many people did Tom score higher than or equal to, not including himself? Well, if there are 36 117s and we don't include himself, then that would be 35 of those people. If you take that number and divide it by how many people were in the whole data set and then times by 100, you will get a percentage. So, home screen, 35 divided by 60, enter, times 100, enter. You'll see that his percentile rank is 58.3%. So he did better than about 58% of the homework. Good deal? It says this number is called the percentile rank for Tom and explains where he falls among the 60 people in the survey group. Good deal. So now it says what's the percentile rank for Susie? So Susie has an IQ score of 127. Now, you know 127 is higher than 117, so Susie's percentile rank should be higher than Tom's percentile rank. And Mark got a 99, so his is definitely going to be lower. So we're going to go ahead and check on here. Susie's 127. So stat, edit, let's find a 127. Okay, so there are two 127s. We don't want to include hers, so not the 48th number, but we do want to include anybody else she's tied with, so that's 127. So 127 is equal to the 47th number, so 47 over 60 times 100. Home screen, 47 divided by 60, enter, times 100. You can see that Susie's was at this 78.3 repeating percentile rank. So that means that she scored, her IQ was higher than 78% of the people. But again, only 78% of these 60 people. Good deal? Okay. So Mark's is on there. You can go ahead and do Mark's, stat, edit, and let's just make sure that I have a, yep, I do have a 99 in there. So sometimes I just make up numbers and they might not have matched up with it. So I'm going to let you do this one your own. So you answer. And this one says if Michelle has a percentile rank of 75, what would her IQ score be? So if you look at this equation right now, if we did this last one, 78.3 repeating percent is equal to 47 over 60 times 100. And now we said Michelle's is 75, so if I get a 75, right, is equal to X over 60 times 100. I'm really just solving that equation for X and finding out which number this is. So how do I solve that? So I'm going to go to my home screen right now, and I'm going to go 75 times 60, enter, divided by 100, enter. And you can see that it's the 45th number. So then I can go stat, and back to that, edit, go down, scroll down to the 45th number, And you can see that that person was a 125. Okay? So at this point right now, I'm hoping that you guys can do this, right? You can enter data into your calculator. You know how to work that out. You can find these basic statistics over here. You can know that there were no outliers. You can create a box and whisker plot. You can create a histogram. You know what both of those things mean. You know if something's a normal distribution. You know that on last night's homework, if you were doing the count 9 levels or the test scores, that data can also be skewed to the right or skewed to the left. You've been introduced to the first statistic called the percentile rank, which just tells you where this score is or that person is compared to everybody in their population. It could be really high if they're compared to people in certain groups, and it could be the exact same person in a different population, and it could be extremely low, right? You could have a person, lights went out, lights go on. You could have the person who finished dead last in the Olympic Games in the 100 meters is still literally probably the 8th fastest person on the planet, but their percentile rank for that race would be at 0. They didn't do better than anybody else. Okay, so now we're going to talk about these things called a z-score. A z-score. And this standard deviation, again, is something that I'm going to show you where it comes from and how it works in class tomorrow, or if this is a previous year, then you'll just know it from some other time. But a z-score is equal to x minus x bar. So x is the actual score, person's IQ. X bar, or mean, is the average. And then this little symbol is called the standard deviation. Now, we need to find out what the x bar and the standard deviation are for this set of data. So x bar is equal to the 115.083 repeating, and the standard deviation was equal to, we have 14.67. 14.67. And for our class right now, we don't need to worry about extra decimal places. Those are good enough. So it says, what is Susie's z-score? Well, Susie's right here. Susie had a 127x. So you're going to do 127 minus 115.083 repeating divided by 14.67. Take that on home screen. 127 minus 115.083. Hit enter first before you do the division, or else it'll only divide the 115 by it. Divided by 14.67. And I get a z-score of 0.812. 0.812. So first off, because I know I haven't told you what these things are, but if the z is positive, that means you are above the 50% mark. If the z is negative, that means you are below the 50% mark. And anything a z of positive 3 or higher, negative 3 or lower, are usually considered outliers. Those are pretty statistically significant numbers. Okay? So you can go ahead and do what Mark's z-score is. Check that. It says Antonio has an IQ score of 142. What's his z-score? So if this number is in the data set, then go ahead and use it from that. If there's one that's not in the data set, then go ahead and put them in and re-answer from that. Okay, so I feel good that you guys should be able to do these ones. And then at the end it says, when looking at IQ scores, what do you think? Albert Einstein's percentile rank and z-score would be blank if he was added to the database above. What do you think about Albert Einstein? Remember, we're talking about IQs. So hopefully you guys would think, oh, and I'm not going to put a number in here for you, but I'm going to say, that better be pretty high. Okay? And the z-score, we just said where z-scores would be. So I'm going to tell you that it's probably going to be in the 3 to 4 range. And again, that's positive 3 or positive 4. Okay, that's, that's at the really high-end mark for that. And then this question says, what would Mr. Troop's z-score and percentile rank be? This is an old sheet, and some of you are like, probably, I don't even know who Mr. Troop is because he's gone. He's our old athletic director, and he was 6'10". So that's kind of why he was in there. So we'll go ahead and switch it into Mrs. Schaefer. And some of you know who Mrs. Schaefer is, and if you don't, you can talk to some other people. Except we're going to change that because of all adult females. And would those numbers change if she was only in a group of WNBA players? Explain. Okay, so think about what that would mean and make sure that you talk to your other people in the class. Okay, so for today, again, this is all I need from you. I need you to complete this entire worksheet, but I need you to be stellar at this stuff. I need you to know how to use this thing perfectly. And the final thing that I need you to do, so that you at least have a background in it, okay? I want you to do some Google research and find out exactly what a standard deviation is, how to calculate it by hand, as well as on your calculator, okay? So not an absolute value, standard deviation, a standard deviation. Good deal? Using means. There should be some squaring going on in your stuff too. Okay, again, make sure you printed this sheet off of Google Classroom, filled it all out, and then submit it to me today. If this is, it'll be March 4th, 2021 if you're watching this video for the first time. Talk to you later.